Accelerated Math 7-8 students, we are now starting our 12th video. The name of the lesson is Writing Products as Sums and Sums as Products. And we can find that on page 28 in my comp book. So I'm going to turn to that. Writing products as sums and sums as products. The goal for today. Today we are going to learn how to apply the distributive property and undo the distributive property. So what we're going to be doing is we're going to be applying it, and then we're going to be undoing it. And you need to know how to do both of those. So the question I want you to think about is, what number can you multiply by anything? And the answer is the number's opposite. Interesting question. What number, so it has to be a number, can you multiply by anything? And the answer is the original number that you're multiplying it by opposite. Kind of confusing, but hopefully you'll be able to figure it out. Okay, quick review, because you guys need to be reminded that we use this stuff all the time. The sum or a sum of money was shared between George and Ben in a ratio of 3 to 4. I know this is going all the way back to 6th grade math. If the sum of the money was $56, how much did George get? Read it again. A sum of money was shared between George and Ben in a ratio of 3 to 4. If the sum of money was 56, how much did George get? I want you to use tape diagram to solve. Okay? And so here's basically, if we were going to use the tape diagram, how we would set it up. Because it's between George and Ben, so the ratio is 3 to 4, George being 3, Ben being 4. And we know that the sum of both of them was 56. Okay? So if you know that all of these sections of the tape are 56 altogether, what do you do? How do you solve it? What do you do? Okay? So the first thing that I want you to think about, as a quick reminder, is what if we called, and it could be any section, I just chose Ben because it was easiest to write it, and we labeled this one section an X. It could have been this section, this section, this section, this section, this section, or this section. It doesn't matter. We're just labeling a single section out of the tape, and we're calling X. So the question that I need you to think about is, what does the rectangle labeled X represent? So what does this X stand for? Okay, well, we've got to figure that out. So if we have 1, 2, 3, 4, 5, 6, 7 sections, and 7 sections equals 56, what goes into each section? Okay, so basically you're going to say 1, 2, 3, 4, 5, 6, 7, trying to make them the same shape and size. Sorry, that was really, really, really bad. But we know all of this is 56, and that there are 7 sections, and I know that 56 divided by 7 equals 8. So what goes in each section? You are correct, 8. And the question was, how much did George get? Remembering that this was George and this is Ben, the answer to the question is George got $24. Okay? And so to go down here, if we labeled this X, what would be the value of X, or what does the rectangle labeled X represent? It represents 1 unit of 8. Okay? So we can use the tape diagrams to help us understand the distributive property. Okay? And so what we would do is we would say X 7 times equals 56. So the way we would write it is you would have X in your parentheses, and then you would do it 7 times, because that's how many sections there are, equals 56. And so what you're distributing is you're distributing the 7 to whatever the X is, and we know that the X equals 8, so we would have 7 times 8 equals 56. Okay? All right, let's keep going with this and see what else we have. The distributive property with tape diagrams, we need to represent 3 plus 2 using a tape diagram, okay? And so what we need to do with that is we have one piece of tape this time because it's no longer a ratio. But we know that the sections of the tape have to be the same. So we have 1, 2, 3, 4, 5. And we're going to cross this part out because I drew it too big and I don't have an eraser. But the way we would represent 3 plus 2 is we know this is 3. And when it's in one tape, we know they're added together. And this would be 2. So this is how you represent the expression 3 plus 2 with a tape diagram. Does everybody see it? Okay. All right. So then if we do that, now represent x plus 2 using a tape diagram. Notice it changed from 3 plus 2 to x plus 2. Well, do we know what x is? No, we know that it's not 2. So, again, we're going to draw our tape, and it could be any amount, right, plus how many? 2. So this right here equals x, and all of the sections added together in one tape are always added together, 2. So this is 3 plus 2. Does everybody see why it's 3 plus 2? Whereas this is x plus 2. Okay, hopefully you guys are starting to see this pattern. Well, then how would we use the tape diagram to show this? Well, basically we have 3 plus 2, how many times? 3 times. So the way we would do that is we would go, right, 1, 2, 3, 1, 2, right, this is 3, this is 2, so they're added together, and how many times will we do that? 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and this represents the 3, right? This represents the 3, and that represents the 2, and we did it 3 times. Okay, does everybody see that? And then what you're going to do with that is you're going to tell me what you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. So this whole thing plus 1, 2, 3, 4, 5, 6. And that's what you come up with. Okay? So now let's do 3 times the quantity, x plus 2. So we're going to take x plus 2, right? That's what it was up there, and we have to do it 3 times. So x plus 2 and x plus 2. Does everybody see that? So how many x's do you see, right? So I see 3 x's plus 1, 2, 3, 4, 5, 6, 6. Okay? And this little diagram represents 3 times the quantity x plus 2. So do you see how we got there? We have 3 x plus 2's, and that gives us 3 x's plus 6. Okay, do you see how this is working? This one up here would be 3 times the quantity 3 plus 2. So we have 3 3's, and we have 3 2's. Okay, are you guys seeing it? So this is how you can use the tape diagram to help you with the distributive property. All right, so let's look at this next one. What is the area represented by the sections of the tape diagram? So these are all x's, these are 2's, and there's 3 of them. So it says the area for the pink rectangle is 3 groups of x. So the answer would be 3x. The area for the blue rectangle would be 3 2 times, and so you get 6. So the answer would be 3x plus 6. Okay, hopefully you're seeing that. Okay, let's turn the page to the next one. So the distributive property means to multiply all parts of an expression by the coefficient. Remember, the coefficient is the number that is multiplied by the variable. And on this next one, we don't have a coefficient because we don't have any variables, but we are going to use the distributive property. And so if you take a look at it, it says, sorry for coughing, 11 times the quantity 16 plus 5. Well, if you count out my tapes, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 in that section. Sorry, and 5 in the second section. And I'm supposed to do that 11 times. Very sorry for coughing, trying to get over my cold. So, I'm going to do it a fast way. You know there's 11 sections in there and 5 in there. Excuse me, 16 in there. Ooh, that's a bad one. So 16 here, 5 in here. That's 3, right? 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so this is what we have. We did it 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically what we're now going to do that we've drawn it out on our tape is we're going to figure out what that is. So 11 16s. 11 16s. Yeah? 11 5s. Okay, so if we do 11 times 16, we get 176 plus 11 5s is 55. And then if we were to add those together, we know that there are 231 sections in those 11 tapes. Okay? Now, if we just did it without the tapes, what is 16 plus 5? 21 times 11. Let's check it. What's 21 times 11? 1, 2, 1, 2, 1, 3, 2. Cha-ching! Do they match? Yes, they do. Okay, so now you can see that a tape diagram is helpful when you're trying to distribute. Okay? All right, so let's try these ones down here then. What you're supposed to do is you're supposed to draw a tape for these right here. So we have x plus y plus x plus y plus x plus y. So if we're going to do a tape like that, we're going to have, we don't know what x is, right? And we don't know y is. We have x plus y plus x plus y plus x plus y. Okay, that's what this says, and that's our tape. So what could we simplify it to? How many x's do you see? 3 x's, right? Plus, how many y's do you see? 3 y's. So your tape shows you what you have. Do you see why the tape diagrams are kind of helpful? Okay, they're very kind of helpful. All right, so let's try the next one. It says x plus x plus x plus y plus y plus y. Okay, so we have x plus x plus x. We know x is all the same thing. Plus y plus y plus y. Again, what do we get when we have that? How many x's? 3. How many y's? 3. So again, we see that, and they just look a little different. Okay? And then last, how would we draw a tape diagram that looks like that? You, again, would go three x's plus 3 y's. So you would do 3 x's, 1, 2, 3, 1, 2, 3, plus 3 y's. Okay? So do you see how we can represent every expression that we're doing with tape diagrams? So this one would be 3x's plus 3y's. Okay? Those are all the different ways you can do it. Very helpful. Okay? So basically what you need to take away from this practice, and it's hard to see with that color, and I'm sorry, the distributed expression is called standard form. So when you actually have it distributed out, this, and this, that's called standard form. Okay? So now let's look at the next one. This was all applying the distributive property. Now we're going to learn how you undo the distributive property. Okay? And so the question says, how do you undo the distributive property? So 8x plus 4 is written as the standard expression. That means you applied it. So this is basically the simplified terms put together. And we can't combine them any further because there's no x with both of them. In order to combine them, this one would have to have an x. Okay? So you take your standard form, and then what you need to think about is you need to say, what do both terms have in common? We have 8x plus 4. So what does 8x have in common with 4? Okay? What does it mean to factor something out? Well, I see that 8x has a factor of 4, and I see that 4 has a factor of 4. So remember, factors are the numbers that are multiplied together to get the answer. So 8x has factors of 2 and 4 and x, right? 4 has factors of 2 and 4 and 1 and 2, right? Because if you do 2 times 2, you get 4. If you do 4 times 1, you get 4, okay? So basically what you have to do is it says, what does it mean to factor something out? It means to find the one that they have in common. So unfortunately, between 8 and 4, they have a lot in common. They have all the 2's in common, or they have the 4's in common. So what we do as a general rule of thumb, and I'm going to write this one again because it looks a little confusing. 4 can be 2 and 2, or 4 can be 4 and 1. So basically what we like to do when we're undoing the distributive property is we want to choose the greatest factor that they have in common. So 2 and 4, 2, 2, or 4 and 1. The greatest would be the 4's. Okay? So if we do the 4's, when you factor them out, that means that you pull them out of the expression. Okay? So we know that 4 goes into 8 evenly, and we know that 4 goes into 4 evenly. So factor out the 4 from both terms, and what that means, remember, factoring out means you divide. So you take your original expression, which was 8x plus 4, and you divide 4 off, which gives you 2, and you take 4 divided by 4, which gives you 1, and you write what you have left over. So we have 8 divided by 4 equals 2x. The x has to stay there because it didn't go away, plus 4 divided by 4 equals 1, because that's what you have. And then you have to put the factored out amount on the front, because that's the amount you pulled out. So we pulled the 4 out, set it outside the parentheses, and we left what was left over from dividing it out inside. So this is how you undo the distributive property. And basically, this is an expression as a product of 2 factors. Okay? So we have a couple that we need to try. And the first one is 72t plus 8. So let's work on it together. 72t plus 8. So we have to think to ourselves, what is the greatest factor that both of these have in common? Well, 72 is 8 and 9. 8 is 8 and 1. So the biggest number they have in common is 8. So that means we're going to pull the 8 out. So we're going to pull the 8 out, and we're going to write what is left over. So again, remember this was 72t plus 8. So we pulled an 8 out, and we're left a 9 in there plus 1. And you have now just successfully undone or undid your distributive property. Remember, this is standard form. This is now in expanded form because you pulled the factor out. Does everybody understand? And then if we wanted to use a tape, we could draw a picture that you have to take 9t plus 1. So we have 9t's, right? Plus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all t's, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, plus a 1. And we're going to do that 8 times, right? 5, 6, 7, 8, because it says 8 right there. So if I do that, how many t's do I have? There were 9 t's in here. 9 t's in here, 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 9 t's in here. 1, 2, 3, 4, 5, 6, 7, 8 of 9 t's gives me 72t plus 1, 2, 3, 4, 5, 6, 7, 8. So do you see how this is exactly the same as this? This is standard form, this is distributive form. Do you see it now? Okay, I hope so. All right, so let's try the next one. Actually, you know what? I'm going to have you try the last two by yourself and see what you can do, and we'll go over them in the morning. So you're going to do 36z plus 72, and then you're also going to do 144q minus 60, okay? So use that same pattern that we've been working on to help you figure it out. All right, my darlings, let's very quickly go back to our question of our lesson. This is a long lesson. I think you guys did a good job, but let's go look. What number can you multiply by anything? And the answer is the number's opposite. I don't know if you got it from there. I want you to play around with that. See what you can come up with. What number can you multiply by anything? And the answer that you get is anything's opposite. That might help you. All right, my darlings, I'll see you tomorrow. Bye.